All right, let's go to the next set of notes. Next notes are concerning a thing called specific heat. Right? In regards to a thing called specific heat, if you think of the words that this topic is about, heat meaning energy that's given off. Right? That's pretty obvious. But then specific, if something is specific to you, then doesn't that mean that it's only for you? Right? It's not for the person next to you. It's not for the person down the road. Specifically for you. All right. So this idea of specific heat is the idea that we can identify the amount of energy for a specific substance. All right. So we can look at any specific thing and we can determine how much energy that object has. All right. It's something that's already been predetermined by science. Excuse me, goodness, man. It's already been predetermined by scientists. So it's just a matter of understanding this. So your notes that you should have already written down, it starts off says, why does a lake feel cold on a hot summer day? And I put cold in parentheses or quotes because remember, there is no such thing as cold. Cold is actually just a lower amount of kinetic energy than something that has a higher amount of kinetic energy. So the higher amount of kinetic energy, the hotter something is. Things that are what we consider cold have less kinetic energy, but everything has kinetic energy. So everything has heat, right? So why does a lake feel cold on a hot summer day, but the pavement in the parking lot is extremely hot on the same day? They're both being exposed to the same amount of sunlight. It's the same temperature outside, but when you get out of your car at the beach and you get onto the black top parking lot and you're like dancing around going, oh my God, oh my God, this is so hot out here. And then you run over to the beach and you get to the sand and you're sand on the sand and you ever notice that even on the sand, it's like, oh my God, the sand's still hot. And you might dig your feet down underneath the sand. Oh, God, it feels better now. Now it's a little bit cooler. Or you keep going, you get all the way into the water and the water's like, oh my gosh, the water feels so much better. Every single one of those, the water, the sand on the beach, and the parking lot are all getting the same amount of sunlight. Why is there such a difference in temperature? It seems like they should all be the same temperature. Well, it all has to do with this thing called specific heat. So specific heat is why, number A, that is why it actually occurs, all right? So letter A, the amount of energy it takes to raise the temperature of 1 kilogram of a substance 1 degree Celsius. So it's how much energy shining down on something makes that temperature go up 1 degree, all right? If we're talking about the same amount of stuff, if I have 1 kilogram of blacktop parking lot stuff, 1 kilogram of sand, and 1 kilogram of water, and I expose them all to the same amount of energy, right? We're going to see those go up different amounts of temperature, right? So it's all about how much energy it takes to actually get them to change their temperature. Letter B, it's measured in a thing called joules over kilograms degrees Celsius. It's a big, humongous kind of a unit, but it's a bunch of different units. And when you really look at the definition, notice that it says it's the amount of energy, that's joules, that it takes to raise the temperature 1 kilogram. Well, there's that mass, kilogram. Well, material, 1 degree Celsius. There's the other unit, degree Celsius. So it's joules over kilograms degrees Celsius. All three things are part of these units. So letter C, water has a very high specific heat compared with alcohol, sand, iron. Water has a really, 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 really high specific heat. What does that mean? It means it takes lots and lots and lots and lots and lots of energy to get the water to change temperature just a little bit. Now I have a pool at home. And when spring gets here, which is going to be about when you guys are watching this video, maybe even be late spring, almost the end of the year. When first spring gets here, it's my pool may be beautiful, right? And the sun's out and it's really, really warm outside. But I go out and put my feet in the water and it's like, oh my gosh, the water is cold. There ain't no way I'm getting inside the water because it's so cold. Right? I gotta wait for this water to warm up some. Well, and it takes days and days and days of sunlight to finally get to the point where the water gets warm enough where I'll finally get into the water. Even though everything's all set and the water's all clear and everything, I've got to wait for it to warm up. And it's because it takes lots and lots and lots and lots and lots of energy in order to get that water to change temperature. But in the reverse of it, the dirt that's surrounding it in my yard, all that stuff warms up a whole lot faster. Why? Because it's a different substance. It's not made up of water. Okay, so my yard will be all nice and warm and the grass is growing and everything, but my pool is still cold and not ready to go swimming in. So what does this whole idea mean? The higher the number, the more energy that has to be absorbed to increase the temperature of a substance. So the higher the number in specific heat, then the more energy it's got to absorb, the more energy it's going to take to get that substance to change temperature. The lower the number, then the less amount of energy it takes. Right? It doesn't take as much energy to get that temperature to raise. So water takes a lot of energy to change its temperature is number 3. Number 4, alcohol, sand, iron. These take way less energy to increase their temperature. And that's why walking across the sand on the beach, it's really, really, really hot. But yet the water is really, really, really cold because that sand changes temperature really quick. Now, you ever notice also if you happen to go to the beach at night, the opposite occurs too. And that is that at night when the sun goes down, that sand actually loses its temperature, it loses its heat really, really quick. And you'll notice that the beach is really cold. But yet you walk into the water and it's like, oh my gosh, the water feels so good. It's so warm. And it's because the water, it takes a long time for it to lose its temperature because it took a long time for it to get its temperature. So I know for myself sometimes when it gets like there's a cool night, it's fun to go out and go swimming late in the evening because the water in the pool will feel what we always call warmer than the air. Because that water in the pool holds that temperature, it holds onto it, and it'll actually feel like a bathtub late at night. And then when you get out, you're like, oh my gosh, it's really, really cold out because the air is colder than the water. The number 5 there, it says, or if you expose all the same amount of energy, then the water will change very little in temperature and alcohol, sand, and iron will increase a lot. So this whole idea on this is if that number is really, really high, right, it takes lots of energy to get it to go up a little bit. Right. So if we expose them all to the same amount of energy, which is like the idea we have the blacktop parking lot, the sand, and the beach, the water, they're all going to get the same amount of energy shining down on them. Well, which one's going to be the hottest? Well, it's going to be between that blacktop and that sand. And the water is going to take a long time to go up. So it's going to go up just a little bit. And that sand and that blacktop, the temperature is going to go up a whole bunch. Okay? So it's going to go up a bunch and change a lot because it doesn't take as much energy to get it to change temperature. So letter D down there, water stays at a constant temperature until a lot of energy is added. So we got to put lots and lots and lots and lots of energy into it. So something I always love to point out now is that you should go tell your mom and dad, thank you. And you'd be like, for what? Well, the one thing that they do is they spend a lot of money on warming up water so that you can take a hot shower. Because we got to stick, I don't want to say we, but your parents have to stick lots and lots and lots and lots and lots of heat into the cold water that comes into the hot water heater that's in your house somewhere. And then we stick all that energy into that water to get that temperature up so that you can take a hot shower. Right? And it's, oops, there goes my light. Hold on. So on someday you guys are going to own a house and you're going to find out and you'll be like, oh my gosh, man, my electric bill is so much, or my heat, my gas bill is so much, and it's going to turn out it's all because of warming up that water inside that hot water heater. Right? It takes a lot of energy to warm up water. Right? So again, tell your mom and dad thank you, and tell them, hey, thanks for spending all that money so that I can take a warm shower, a hot shower. Right? Now at the very end there, it says there's an equation. Notice on that it says that specific heat equals, and in order to do this equation, which is something you'll have to do inside of a quick lab, is you're going to take the heat divided by, and then you have the change in temperature times the mass. All right, so that's the equation that we would use on this, and change can be this, it can be a triangle T, right? Because the triangle means change. So, all right, well, that finishes up the notes on this one. So, see you next time. Have a great day.